Thank you for being here today. Today I would like to explain full flow valves and how the valves can help your system from overpressurization. This is a picture of the old facility down the street, which we moved to our new facility back in 1989, so 22 years ago. This class today is on Valves 101 for application, selection, sizing, considerations on the full flow guided piston relief valves. My name is David Locaputo. I'm the general manager and the engineer here at Fulflo. So if you have any questions or whatever, you can feel free to contact me at dlocaputo@fulflo.com for questions, quoting, better explanations for future conversations. Today we want to discuss the training itinerary, Fulflo is, the relief valve introductions, relief valve applications, system types, advantages of the Fulflo guided piston relief valve, the different series that we offer, the V, the FV, the OVA, and SVB. Each one's a little different. We're going to talk about how to size the correct relief valve for your application, discuss some valve failures, watch a short video, and then questions and answers at the end. So here's a picture of our current facility, which we moved 22 years ago, located at 459 East Fancy Street. It's a state-of-the-art one-floor manufacturing facility with the offices on the second floor. So it's 42,000 square feet of facility. Here is an overview of the shop floor. You can note how clean the floor is, how organized everything is. That way we can keep production flowing.
Is Ryan not going on site a lot? He used to.
On the relief valve introduction, Fulflo is used in industrial systems to prevent pressure buildup that exceeds the equipment design limits. It's an API 520 and 614 approved valve. For those that don't know, API 520 covers the standard that applies to the sizing, the selection of pressure relief devices used in refineries, chemical facilities, and related industries. API 614 approved covers the minimum requirements for the general purposes of oil systems. Lube oil systems that meet API standards operate an extreme high level of efficiency, which decreases the cost of operation and decreases the downtime of the rotating equipment. The relief valves are also for overpressure conditions that could cause the upset of damaging to the equipment, the filters, the pumps, anything within the system that you have. The full flow valve is not for air, gas, or steam service. Air, gas, and steam will just vent right through the relief valve, where oil and a fluid will not. And I'll explain more about that here shortly. Typical applications that you'll see here, but they're not limited to. The typical ones that we see is application number 1, where the relief valve is pumping into an open tank where there is no back pressure on the relief valve. Where application 2, the valve pumping into or flowing into the closed tank, that tank is pressurized, which would affect the valve set pressure. The valve does work off of differential pressures. Typical application number 3, the valve's pumping out of a pump, which could be a centrifugal pump, a positive displacement gear pump, where it's pumping back into the suction side of the inlet of the pump. Application number 4, it's just circulating within. A lot of times you find these for PD pumps, positive displacement. Key valve types. Basically, the pressure safety valve, a PSV is what people call them the most, is a safety valve. It's a safety valve that's actuated by the inlet pressure, and it's a rapid open and a rapid closed popping valve, where when the valve opens, you're going to hear a loud bang. That's the valve opening. This is not a safety. This is not a full flow valve. That's a safety valve strictly for safety only, not designed to operate. Strictly there for safety reasons only. But the full flow valve is more of the conventional relief valve, regulating valve, modulating valve, whatever people want to call them. They're really classified as a conventional relief valve. The spring-loaded pressure relief valve is where the valve would open, controlling pressure, but it does work off of the differential back pressures. This is all the full flow valves except the OV series valve, where the OV series valve is a balanced pressure relief valve. It's spring-loaded pressure relief on the inlet of the valve, but the back pressure does not affect the set pressure at which the valve is going to operate. That's the OV series valve, which we'll talk about as well. Overpressure in a system is the pressure rise or accumulation above the set pressure when the valve is discharging flow. So overpressure could be a percentage of what the valve is set for. Differential set pressure is the difference between the set pressure and the constant superimposed or a variable superimposed back pressure. Where back pressure is just the pressure that's affecting the discharge side of the relief valve due to the pressure in the system. That could be the constant or the variable. So it's a sum of the buildup of pressures. The three pressures that you find in that are the three most critical ones that you'll find in a full flow valve would be the cracking pressure, the set pressure, and the full open pressure. The cracking pressure is the pressure at which the valve starts to leak a little fluid through the valve before the set pressure. It's also based on the viscosity of the fluid. Water is going to leak a lot sooner than oil will because it's going to vent through the valve and on out to the discharge, where a higher viscous fluid will not do that because it can't leak through the valve and back out. So that's cracking pressure. Set pressure is the pressure that the valve is adjusted to open, maintain, and control the service conditions. This one you get to choose. You can determine if you want the valve to be set at the operation set pressure or a higher percentage set pressure, but then the springs would be adjusted for that. Full open pressure is the pressure in the line where the valve is relieving full process flow. It's the set pressure plus the overpressure, which determines the full operating pressure at that point. Basic valve operations are when the valve pressure in the system reaches the predetermined set pressure. The relief valve will open, divert some of the fluid back away from the process, trying to maintain a constant pressure. So as the pressure would increase, the valve would then continue to open or close based on the prevailing pressures at that time. As the fluid is diverted, the pressure in the system will stop rising for a moment of time, or can maintain continuous duty regulation. The pressure stops rising, then the fluid is going to be diverted back to the tank until the valve would then be required to open or close at that point. As the upstream pressure decreases, the valve will gradually close back to the setting of the valve. where in the full flow valve, there is no blowdown pressure. In a safety valve, a blowdown would be the valve would be set at a predetermined set pressure, then would reseat at a percentage lower than the set pressure. Where in a full flow valve, the valve will be opening at a set pressure and reclose at that same set pressure. A typical example that we run across is when you have a manual shutoff in a system, going to the loading system or to the process, the manual valve could be shut off, which would increase the pressure to the pump. At that point, you're going to cause a lot of stress and strain on the centrifugal pump or positive displacement pump. So what we do is we would insert the full flow relief valve after the pump in this location here. The recirc line back to the tank is added and the full flow valve installed would relieve the pressure. So now a centrifugal pump that's continuously bypassing doesn't get into a deadhead situation. All PD pumps, positive displacement pumps, need an external relief valve for system, piping, filter protection. It would be installed in the same location and can be mounted in any position, upside down, right side up, does not affect the set pressure, the operation of the valve, or anything about the valve. That's unique to the valve industry. Typical applications that we run across for the full flow valve is process equipment, pumping systems, oil burners for the regulating the fuel to the boiler. That would be our SVB-Series valve, lubrication oil consoles, lube skids, that type of thing. The compressor skids, loading rigs, similar to the example that I showed you before, that could be going to the loading rig, loading a truck or a ship or something to that effect. And once the truck or ship is full, the shutoff valve will be closed because the tanker is full. Therefore, you're going to get into a bypass situation. It's just a seal saver for a centrifugal pump where the pump doesn't have that strain on the mechanical seals. And then on a safety, the PD pump, that would protect the system from overpressurizing and something in the system blowing up. Parts washers, we get into water chiller systems, tunnel boring, mining equipment for lubrication of the bearings. We get into the engine dynos for the water brake systems. As you see in the picture on the right, in red, the full flow valve is mounted in the bottom of the dyno, and that would be for the water brake for that dyno. You can see the picture above it, the full flow valve mounted in the horizontal position, constantly regulating that system pressure. Or the blue valve located in Texas in a oil refinery. Here's an application here for a parts washer for a hot water application. On the bottom right, you have the pump pumping to the spray heads. But when the spray heads do not require the flow anymore, you get into a bypass situation. The valve, the pressure is backed up into the bypass line. The pressure gauge would then reflect that and be dumping the water back into the tank. You can have that spray head be shut off continuously and have a loop out of the pump into the relief valve into the tank for continuous duty. Here's an application, full flow relief valves protecting gusher pumps, vertical pumps. We have them gear pumps, which is the Brown and Sharp gear pumps located in the tank, where the full flow valves are protecting both pumping applications. Very unique. The flagship of the Fulflo bypass relief valve, it's a chatter-free performance. So as the valve is operating, it's very smooth, it's very quiet. You don't hear all the pipe strain and chattering that you would see and hear in most safety relief valves or relieving conditions. So Fulflo has a definite advantage when it comes to that application. The constant pressure regulation, the continuous duty, all is unique for a Fulflo relief valve. The Fulflo valves are UL approved for boiler applications. We have Canadian registration certified for the steel, the stainless steel, and the cast iron valve, which is a new approval for the 2-inch valve and lower for smaller. We have a RoHS compliant material certifications where we have the reduced lead in the brass valves, API 520 and 614 approved. Fulflo valves are very reliable, very dependable. Don't have a lot of returns when the valve is sized properly. You put the valve in the system and they tend to forget about it. So it's kind of a unique thing then that Fulflo valves can work under those conditions. They can be mounted in any position. Again, that's unique to the valve industry. They can be shipped in any position, where most safety valves are shipped in the upright position. The valve range, our advantages, we have the cast iron class 30 material for the castings. We have WCB steel, 360 brass for water applications and corrosive applications, as well as a stainless steel CF8M material. We range from 3/8 to a 4-inch valve. Flows are from 0 all the way to 600 gallons per minute. Pressure ranges up to 1500 PSI on selected sizes only. The flexible internal design, we can interchange different O-rings, different pistons, different springs. So if the valve is in the field, you can take one spring out, replace it with a different spring to generate a higher pressure or a lower pressure. They're very durable. We build them to last. Here is a Roth regenerative turbine pump. This is their literature where it shows the Fulflo valve or equal in their actual literature, showing that our valve is designed to protect their pumps, and it's the preferred valve. That's Roth regenerative turbine pumps. Typical series on the Fulflo valve, we have the SVB-Series valve. We have the V-Series valve, which is probably the most popular. To the right, the FV-Series valve, which is starting to take over the V-Series by population. The A-Series valve and the OV-Series valve, which is a newer valve for Fulflo, and I'll explain that operation here shortly. You can see we offer them in NPT flanges. We have different connections dependent on the application. So to understand the valve and how the valve operates, the valve is normally in the closed position. If you follow the red arrows up on the closed drawing, the piston being enclosed, it's down and sitting on top of the stop ring, which is a ring that is expanded metal inside the relief valve body that would prevent the piston from being forced out of the valve. The stop ring is expanded metal, so it's not something to be replaced, but it's a positive stop for the piston from the spring on the other side, pushing the piston out of the valve. So what we have here is the pressure is inserted on the bottom. As the pressure is overcoming the spring set pressure, the valve would hit the set pressure to the right, which is the horizontal line, left to right. So the bottom of the piston lines up with that horizontal line. You're right at the set pressure at which the valve's going to start to operate. The valve will sit there at the set pressure or be half open or full open, determined all by the pressure on the inlet of the valve. As the pressure would increase, the valve would just open up further and further until the valve will be fully open, dumping the pump capacity of what the pump is delivering, and can sit there and operate continuously up and down all day long. Again, it doesn't have any chatter in the system. So as the valve is operating, it's very quiet and smooth, which gives you and maintains a constant line pressures. Now into the series valves that we offer, the V-Series valve. We range from 3/8 to 2-inch ports. That's how you know you have a V-Series valve if it's 3/8 to 2-inch, where the connections can be NPT connections, flanged connection, SAE, O-ring boss connection. We have socket weld for the steel and the stainless steel valves only. The flows are from 0 to 150 gallons a minute. If your flow is over that, then you need to go to the next series up. Pressures are up to 900 PSI. They are fully adjustable, and that determines the size. The 1 inch and the 1.5 inch, we can take up to 900 PSI. Normally, our relief valve pressures are up to 500 PSI. But selected sizes and selected springs can get you up to a higher pressure. The steel, cast iron, brass, and stainless steel are the product material offerings for this series. Chatter-free operation, continuous duty, mounts in any position. There are specials available depending on the application. You'll probably need to consult myself, David, to get sized into a special model number, and that model number determines what's special about it, but I would help you with that, so feel free to call me for that. This is a typical disassembly of the relief valve. In this series, you will have liquid that will vent and fill up the cap full of fluid. The cap will be full of fluid. The O-ring underneath it will prevent it from being escaped out of the valve. And it won't really be pressurized, but it will be full of that fluid. With the adjusting screw in this valve, when you adjust the screw in or out, you can actually back the screw out too far, and the screw can come out. So we determined that this possibly could be a problem. So we designed and created the new series valve, which is the FV-Series valve. The FV-Series valve is the safer leak-free cap. Being that it's safer, you do not have liquid in the cap. You can take the cap off of the valve and leave it off, or put it on to keep people from making adjustments to the valve. In this series here, when you back the screw out, the screw backs out so far and it stops. It can't be backed out all the way. So with it being a leak-free cap and the screw not backing out, it would equal a safer design. It's also offered in the 3/8 to 2-inch ports, same NPT connections, flange, SAE, and socket weld. Flows up to the 150 gallons a minute and pressures to 900 PSI. We also offer this in the steel, the cast iron, the brass, and the stainless steel, and that's all determined by the application and the media of the application. Chatter-free, continuous duty, mounts in any position. And this too, we also offer in specials. The FV-Series valve, as you see here, the adjusting screw has the O-ring incorporated onto the hub, the thicker part of the screw. So when you insert it into the bottom of the bonnet, you can back it out so far and the adjusting screw will stop. The O-ring on the adjusting screw would prevent the fluid from getting up into the cap, So if you're dealing in a hot water, hot oil, or chemical application, it's not going to be exposed when someone would take the cap off of the valve. So that's what makes this valve more superior over to the V-Series valves. On the piston itself, the old design piston had a milled slot on the bottom of the piston, where the newer series valves are flat bottom, but they have a chamfer around the circumference of the piston, which would allow equal distribution of the fluid as the valve is at the set pressure. Where the V notches, the old design, would allow the fluid to go through those V notches in the 4 different quadrants as the valve is opening and closing. So the new style of piston, flat bottom, is superior to the old design. With better technology, we're able to make that happen. The OV series is a unique animal. It's for special applications where you have a variable back pressure that's affecting the valve, which would also be changing the set pressure at which the valve would operate. The OV series is a balanced pressure relief valve for variable back pressure applications. With the O-ring incorporated on the piston itself, it's a wear part. So the wear part, when it wears out, you're going to have fluid possibly leaking out of the hole that you see located on the side of the body. I'll explain that here shortly. It too is API 520 and 614 approved. This is the range size that we have instead of 3/8. It's sized from 1/2 inch to 2 inch. The pressures on this valve is up to 500 PSI maximum. The connection is NPT and flanged only, where the steel, the cast iron, brass, and stainless steel are the materials of choice based on the application. Shatter-free operation for continuous duty also can be mounted in any position. So as I was saying, on the body itself, there's a small hole. That's the breather hole. It's the vent as the piston would slide up and down inside of the valve. The pressure would exhale the air that's inside the spring chamber as the valve is opening, and it would inhale air as the valve is closing. The O-ring there would prevent the fluid from getting up into the spring chamber. And you can also note there is no holes in the piston itself, as it's a solid plunger up and down. Here we don't have to worry about any fluid getting up into the cap because it won't even be getting up into the spring chamber at all. The size 2.5 and 3 inch and 4 inch valves are the A series. So when you exceed the flow capabilities of the V series, the FV, and the OV, the next sizes up are the A series valve. All of our valves are really the same. It determines what the flow capacity is, determines what size or series you would get yourself into. Here, the A series valve, 2.5 through 4 inch. On the direct acting valve, where we have 2 to choose from, direct acting and pilot operated. The direct acting goes pressures up to 150 PSI with connections of MPT and flange mount. Flows from 150, which is where the V series leave off, all the way up to 600 gallons a minute in a 4 inch valve. Steel, cast iron, and stainless steel are the materials, where for water application, we would use a cast iron or steel valve with internal stainless steel and brass internals for water applications. It's also the chatter-free continuous duty and also can be mounted in any position. Typical disassembly, it's basically one valve inside of one housing. It operates the same as the V series, the FV, and the OV. It's just a larger for the larger capacity of what the valve can relieve. The A-Series pilot operated is for a higher pressure. As you see here, the valve can operate from 50 to 500 PSI, where the direct acting stopped at 150 PSI. This valve can be offered in the 2.5, 3, and 4-inch ports. We do have special size, special design where we can take the pressures up to 800 PSI by special order, by special model number. And you can call and we can provide that number for you. Here are the flows from 150 to 600 gallons a minute as well. Same NPT and flange connections, materials, chatter-free mounts in any position. Also can be used for continuous duty. The A-Series pilot operated valve is really two valves inside of one housing. The pilot valve at the top with the pilot piston and the main piston lower from in the main cylinder. In this series of valve, how the valve would operate, the pilot piston would open, allowing approximately 5 to 8 gallons a minute fluid to bypass across the discharge before the main piston opens up. When the main piston opens up, you're going to see that's the set pressure at which the valve's going to actually control pressure. Everything before that we call internal leakage, or just the nature of the design of the valve. As the main piston would open, it's going to regulate the pressure. As the pressure would drop back down, the main piston would close and the pilot piston would close as well. So there's two valves inside of one housing. Here's a typical valve under test. You can see the fluid being dumped out of the discharge of the valve. That's in our test stand here at Fulflo. All Fulflo valves, before they are shipped, are set to the mid-range of the spring or to the specific set pressure that's determined by the original order from the customer. So normally we set them at the mid-range or the specific set pressure per the application. But 100% of the valves are tested before they're shipped. We want to make sure before the valves are shipped that they're lubricated inside, and we want to make sure that they work before the customer gets them. The SVB-Series valve is a UL 842 approved valve. The 842 is for valves that are intended to be used to control flammable fluids and vapors. For the fuel oil, number 6 fuel oil, whatever, going to the boiler, it's going to regulate that pressure. As the boiler might shut off, everything is dumped back through the relief valve to protect the pump, gear pump, whatever it may be, from overpressurization. Here the Fulflo valves are sized from 0 to 150 gallons a minute. Pressures are up to 500 PSI. What's unique about this valve, it's really the V-Series valve that we incorporate a limit collar on the adjusting screw to prevent you from adjusting it no more than 25% higher of the set pressure. So on this valve, per the application, when you're ordering the valve, we need to know the set pressure to determine where we're going to set the limit collar. It's also for chatter-free operation, continuous duty, and normally is mounted in a horizontal position, but can be mounted in any position. There you have the cap at the top, the gasket that prevents the liquid coming out of the cap area under normal operation. And the limit collar is silver soldered to the adjusting screw. That you screw the screw in or out, but once you screw the screw in, the limit collar would prevent that overpressurization more than 25%. And we would need to set that here at Fulflo. So once the valve is set, you really are limited to the low and where the limit collar would be set at which the valve is going to operate. Fulflo Manufacturing, quality and manufactured 100% in the USA. All machining is in assembly is done here in Blanchester, Ohio. We do have domestic castings. We do not buy anything internationally. Everything is strictly here in the States. Tight quality control, DFARS compliant material. DFARS compliant is for the defense to make sure that the products are originated by raw materials. So we are DFARS compliant company. The bottom left picture here shows a special valve that we specially manufacture for a lube oil console. It has 8 different ports into one body. So that goes to show you the capabilities of what we have here at Fulflo and what we're able to accomplish instead of just the in and the out of the normal relief valves. That's a special valve that was specially engineered for the customer, and we supply quite a few of these every month to that supplier or to that customer. Manufacturing Fulflo, every valve is tested to ensure the operation. Once the valve is assembled, it is stamped and then tested. As you show here, the guy on the right is stamping the valve model number. That model number is located on the back of the valve. Once that is accomplished, the orders are set and ready for testing, ready to be shipped and out the door to the customer. This is an example of the manufacturing of the relief valve. The VJ, the V is the series of valve, J is the material. Here in this case, it's cast iron. The 5 would be a 1-inch valve, and the R would be the O-ring located under the cap. The piston material on this valve is hardened steel, which is the HS. The US is the spring. Range on the US spring is 7 to 35 adjustable, but here the customer wanted us to set it at 25 PSI. So it was set to 25 before we ship it out the door. The HJ and 11 is the date, the year, and the month at which this valve was assembled, and we use this for traceability purposes to know where the order came from, who it was supplied to. If we have product recall, we can go back and trace that. Valve selection. How to select the correct valve for your application. Things to consider. Understanding that Fulflo valve works off of differential pressure. So therefore, if there is a back pressure, we need to know what that might be to determine the correct setting at which the valve would operate. One thing on the valves, they're not designed to be tight shutoff. They will pass a minimal amount of leakage before the set pressure. That is due to the fluid venting out the discharge, where water will vent out sooner because of the viscosity being lower than oil. It approximately is 10 to 15% below the set pressure at which the valve's going to start venting that fluid. The size of the valve, you want to size it to the maximum flow that the pump is going to deliver on a positive displacement pump. On a centrifugal pump, we normally divide the flow by 4, and that's what we would size the valve to. That keeps the centrifugal pumps from getting into a deadhead situation. So fluid viscosities have a big play at which the valve's going to operate. So we classified as the SSU, the specific gravity, the centipoise, centistokes. Those are the numbers that were required if you get into a very viscous fluid. temperature of the application, for materials, for the O-rings, that type of thing. So having that information, you would hopefully get the information, be able to plug it into an ISA data sheet. It's just a information gathering piece of paper that shows the application. So I have this broken down into 3 different parts: the top, the middle, and the bottom. So here this is what a Fulflo ISA data sheet would look like. You have the tag number if the customer has a specific tag. The valves are strictly for liquid service only. It would have the model number, the size, the connections, the body and the cap materials, piston material. So as you gather this information, you're able to utilize that to determine what the model number would be. Here at the bottom of the ISA data sheet, it a lot of times specify Fulflo or equal or just Fulflo. The model number would be determined or can be selected and then jotted in there for the model number. And this could be provided to engineers, customers that want to have traceable documentation on the valves. So once you have the information from the ISA data sheet, you would go to the valve configurator on the Fulflo website, fulflo.com. There you can choose if you want to use metric or imperial units, or you can use the gallons per minute or liters per minute. You can get into PSI or bar, but there's some choices there, and I'll show you that here shortly. So once you have the information, you would definitely have to have the pump flow, that's required, the valve set pressure at which the customer wants the valve to operate, and everything else that follows suit is from the application. The pumping media, the connection, the customer might want flange mount, 150-pound flanges. You might want the material of an O-ring to be Viton, that type of thing. So we gather that information and go to the Fulflo website, and we get into the valve configurator. Here we would enter in the gallons per minute. In this application for 24 gallons per minute, the customer would want the set pressure of the valve to be 87 PSI. He would like to have a brass valve and an oil application for NPT connections. The O-ring material to be Buna, which you see the little arrows to the right, and you can select that to choose different materials based on the application. The piston material, we here in this valve here, we're going to go with a hardened steel piston, and the temperature is 145 PSI. So once you go to the website and you enter the information from the application, you hit submit at the bottom, and the computer will generate you a model number based on the inputted values. Here we show 4 different series valves that are all to be 1 inch because we're only dealing with 24 gallons per minute. You have the VB5R with a hardened steel piston and a WS spring. The WS spring range is 30 to 100. And again, the set pressure was 87 pounds. So 30 to 100, that valve would work. Or we also have the same model number with a different spring, the spring 60 to 175, which is the excess spring. That also would work for the application. Customer might choose, does he want to work toward the low end of the spring or to the higher end of the spring? You also get the choice of the FV series valve. So the V or the FV series is what your choices are, and you can see the rest of the model numbers are the same. The View Series Catalog, once you click on that, it would bring up the product offering that would support that model number of valve. This is all located on the home page of the website. So how to read a performance chart. The performance charts are in here to determine what the accumulation pressure is going to be with a given flow. This is used to prevent systems from working off of the maximum allowable working pressure to make sure that the system's going to be well protected. So reading the performance chart, one for each sized valve. This here is, again, the 1-inch valve test. You would go up the left of the curve for the gallons per minute to 24, which is just under the 25 line. Go across to the right, and we'll work off of the first application was for the WS spring. So you go across to the right and you'll find the WS spring to be the third diagonal line to the right, and you drop straight down. You're approximately 16 PSI accumulation pressure. So 16 PSI above the set pressure at which the valve is going to operate. So in this case here, if the valve was set at 87 PSI, you're going to be at about 103 PSI when the valve is fully dumping 24 gallons per minute. You can go from the bottom of the curve on the overpressure. If you know the valve is set for 87 and your pressure gauge is reading 103, you can say, okay, 13 pounds or 16 pounds above where you know the valve is operating, go up to your diagonal line and go across to the right to give you your given flow at that pressure. So you can kind of read it both ways. And these are actual valve tests that we have performed here on our test stand with 150 SSU fluid. And these charts are good from 30 to 500. So that's water up to 500 SSU fluid. The right of that curve at the top right, you can see the pressure ranges to determine what those are based on your application. So if you change it to the XS spring, 60 to 175, you can use that spring as well for the 87 PSI set pressure. Do the same thing. Go up the left of the curve, go across to the right to the XS spring, which is the fourth one over, and drop straight down to determine what the overpressure would be in that case. This is a short video on Fulflo that I'd like to share with you today.
We are Fulflo Specialties company. Hello, my name is David Locaputo, the general manager. Fulflo is the global one-stop source for the original hydro bypass relief valve.
Home of the workhorse valve of any handling system, offered in sizes ranging from 3/8 inch to 4 inch in cast iron, carbon steel, brass, and stainless steel, and pressures ranging from 0 to 1000 PSI. Our engineering department is available to assist customers with specific needs that do not meet the standard product line to ensure you get the correct valve for your application. Quality has been the key to our continued success. The Fulflo story begins in 1912, where it started as one of the first manufacturers of coolant pumps. In 1922, after World War I, the Clifton brothers bought and moved what was then known as the Fulflo Pump Company to the small village of Blanchester, Ohio, located 40 miles northeast of Cincinnati. It was there it became incorporated in 1933 under our present name and trademark, the Fulflo Specialties Company. Then developed and acquired the patent for the guide piston direct acting pressure relief valve designed by the Clifton brothers in 1935, whose family retained ownership of the company until 1982. Fulflo Specialties Company was then purchased by Thomas R. Ruthman, and it remains part of the Ruthman family of companies to this day. In 1998, Fulflo moved to its current location, a state-of-the-art 42,000 square foot manufacturing facility less than a mile from their original location, to ensure that the growth of our business goes uninterrupted to meet the demands of our customers.
the customer's the boss. That's what I've told them all.
An essential part of the world's manufacturing process today, full-flow hydraulic relief valves operate effectively with all types of liquid in a full range of viscosities. The full-flow valve is for liquid service only, no air, gas, or steam. The full-flow valve is used for continuous duty, pressure regulation, back pressure control, pump bypass relief, elimination of pump deadhead, and pump system balance, all with a chatter-free performance. One valve can do it all. Full-flow valves can be found on compressors, lubrication skids, ships, tugboats, oil and gas refineries, U.S. aircraft carriers, and all types of pumps from positive displacement pumps, centrifugal pumps, to positive regenerative turbine pumps, just to name a few. The full-flow valve is designed for system protection and to relieve system pressure. Fulflo Specialties company, that pioneers in fluid power, has become the worldwide leader in the hydraulic bypass relief valve industry. The employees of Fulflo maintain a common focus on all manufacturing processes, from customer service to sales, engineering, to production, assembly, testing, and shipping. The goal is to ensure the highest level of quality and services to you, our customer. Our quality is remembered long after the price is forgotten. We are proud to say all full-flow valves are manufactured and assembled here in the USA.
Thank you for taking the time out of your day to watch our video. For more information on full-flow valves, please visit our website, www.fulflo.com. And thank you again, and have a good day.
So getting into valve failure, why would a valve fail? As the valves are installed in applications, we get into rusting and corroding of some parts. A lot to do with the wrong material of construction based on that application. The cast iron valve is not good for water, where the brass and the stainless steel are. Basically, it would be just like putting water in your car engine. So we don't want to choose the wrong materials. We want to ensure that the application is well filtered. We have a lot of erosion on the parts for abrasive fluids, such as like a water, salt water. We would use the correct materials to get the proper valve to keep it from failure. The main reason why the valve would fail is the piston inside is sticking. There's contaminants in the bore that could be anything from thread sealant, plastic pipe dope for the threads. We get into burrs, weld splatters, just dirt, sand, and grit. That would all prevent the piston from sliding inside the valve. So once the application is a clean fluid, usually the valves are installed and no one ever have a problem with the valves. When you do have the problem and the piston is sticking inside, you're going to get the excessive leakage. The valve will be worn out, maybe due to the salt water eroding the part, where the valve's just not going to close off. The V-Series, the FV, and the O-V-Series are more of a throwaway valve, where the A-Series valve, you can totally take the valve apart, replace all of the internals back to an original manufacturing valve, where the V-Series is more worn out and you just throw it away and get a new one. So there's not a whole lot that goes wrong with the valve, which is kind of nice because once they're installed in an application, they're built to last, they're built to stay there and not be replaced. Fulflo is manufactured and assembled in the USA here at this location, 459 East Fancy Street, Blanchester, Ohio, 45107. The website fulflo.com would have more information pertaining to the valves, the applications, if you guys would choose to go to the site for that. If you have any questions, you can feel free to email me. I'm contact us, and I'm the first one down on the page. But that's today's presentation on Fulflo and what Fulflo can do for your application. Thank you for listening, and if there's any questions, feel free to email me. We can talk further about that. My phone number here at Fulflo is 937-783-2411. Thank you.